The question says find the integral of root 1 plus 3 tan x all over cos squared x between the limits pi by 4 and 0, between 0 and pi by 4, by using the substitution u equals 1 plus 3 tan x. Now look at this term. We cannot integrate this directly, so either we have to use integration by parts or by using a substitution. And the question says use the substitution, and the substitution is given. So how do we do this? Now this is what we call integration by substitution. That is to say, we are substituting x with y. So wherever there is x, we need to replace x with some function of y. So we need to replace dx by du and so on. And we also need to replace the limits in x by the limits in y. So let's begin. So it's given that 1 plus 3 tan x. The first thing to do is replace dx by du. And how do we do that? First of all, we have been given this, and from this we can do that. If we find du by dx, this is 0 plus 3, this is sec squared x, and look, there's du and dx, so this is dx 1 by 3 sec squared x du. Therefore dx and this 1 by 3 sec squared x du are the same, so we can replace dx by this term here. So one thing is done. Another thing is we need to replace everything else as well with u. So here the limits are in x. Since we are integrating with respect to x, the limits are of x. So we need to replace the limits with u as well. That is to say, when x equals, what's the higher limit? The upper limit is pi by 4. U equals, what's u? 1 plus 3 tan x. So put tan x here, put pi by 4 in here. So this is 1 plus 3 tan pi by 4. Make sure that your calculator is in radian mode, and type this out. You will get 4. And when x is 0, u is 1 plus 3 tan 0, that's 1. So limits are in x, and we have found the equivalent limits in u. So dx is replaced by du, limits in x are replaced by limits in u, limits in x are replaced by limits in u. Now just we need to replace whatever x here is with u. So let's do this. So find the value of this. Now this is integration by substitution, so let's substitute. What's pi by 4? Pi by 4 is 4. That's 0. 0 is 1. What's this term here? 1 plus 3 tan x is u. Therefore root of 1 plus 3 tan x is root u. And we can't do anything about the cos squared x, so let's put this as it is. And what's dx? Dx is this term here, so this is 1 by 3 sec squared x du. So we have replaced everything, and as you can see, you may say, this is creating a problem, but cos squared x times sec squared x is 1, because this is cos squared x and sec squared x is 1 by cos squared x, so these two will cancel each other out. Now a good thing to do is The constant 1 by 3 is a constant that has no role to play in the integration, so let's bring that out. It will make our job a little more, let's say, simple, because we don't need to involve 1 by 3. This is 4. This is root u. What's root u? It's 1 by 2. And cos squared x times sec squared x is 1. So du. Okay. So this is 1 by 3. What's the integration? That is u to the power 3 by 2, 1 by 2 plus 1, divided by that. So that is u to the power 1 by 2 plus 1 is 3 by 2, divided by 3 by 2. Okay, this is by 2 divided by 3 by 2. This is just simple integration. This is 2 by 3 u to the power 3 by 2. So integration of this will give this, but 2 by 3 is a constant, and again we don't need this, so while integrating, so just put the constant out, and look, it just makes the work more simpler. And this is 4 1. Yes, integrate. So what? Nothing, just integrating. Just the constant I have pulled out, and this is, just simple work. 2 by 9, 4 to the power 3 by 2, excuse me, 2, this is 2 by 9 times, this is 8 minus, this is 8 minus 1, that is 7, and this gives us 14 over 9. So this is how we go on doing integration by substitution. Just remember, replace, so you are substituting x with u, so replace everything with u. So dx by du, the limits in x with limits in u, and just put the values in. And don't worry if you cannot replace something. In this case we cannot replace cos squared x, just don't worry, it will cancel out, because you can see cos squared x, sec squared x, they cancel out. So just don't worry, just replace and work on and integrate simply, and you will get the correct answer with the correct process. Thank you. Okay.